I can put it on again, but my name is here.
Ash, see? Yes?
Yes.
Yes.
You got it?
Yes?
Okay.
Okay.
And there's 3 other fellow jitzers whose name we don't know.
No, it's okay.
All right?
Yes.
Yes, so we'll give it a start. Right?
Yeah?
Fine. All right. Dear colleagues, good afternoon. A very warm welcome to the first session of the GeoN mod track. I need to briefly introduce myself to all those present. My name is Hartmut Asche of the University of Potsdam, which is just outside of Berlin in Germany. I'm one of the co-organizers of the GeoN mod workshop, and it is my pleasure to chair the first session that we are now going to begin. We have 4 presentations in this session. Each of the presentation has an allotted time of 15 minutes. I've already mentioned to those presenting that we please keep to the timetable so that we finish in more or less over an hour and be on time for those who want to take a break or then change the session. This 15 minutes times includes 1 or 2 questions that I would encourage everyone to ask. Right? All right. So then we'll start with the first presentation. The first presentation is called Earthquake Prediction based on combined seismic and GPS monitoring data. The authors are Valery Giitis, Alexander Derendyaev, and Konstantin Petrov, all of the Institute for Information Transmission Problems. And we have Alexander as the presenter. So yes. I give the floor to you. Please go ahead, Alexander.
Thank you. So I'm Alexander Derendyaev from the Institute for Information Transmission Problems, and I'd like to tell you about earthquake prediction based on combined seismic and GPS monitoring data. Is it okay with my voice? Do you hear me?
Yeah, it's fine.
Okay, great. Thank you. So in the beginning, I'll speak about our motivation. Then I tell you about preprocessing GPS data and then preprocessing seismological data. Then I show forecast results and then move to the summary. Mm-hmm. So we develop a web-based system that makes a systematic earthquake forecast. On every step, the system loads new data from different servers and then learns on new and previous data, and then updates the alarm area for the time interval before the next update, till the next update. Mm-hmm. So previously, we used only seismological data to make a forecast, and now we are trying to include GPS data in our model. Before that, we have 2 questions about GPS data. The first, are they effective at all? And the second, if yes, will they improve the earthquake forecast? Of course, we can answer if we know a GPS processing method and earthquake prediction method. So for prediction, we use our machine learning method called the method of minimum area of alarm, quite big, and I'll skip its description here due to the time limit. But you can find for it in, for example, in Frontiers in Earth Science. The one thing from this paper you should know now is how we determine the quality of the forecast. The first, it defines with 2 fractions. The first U is the ratio of the number of successful forecasts to all target events, and the second V is the average fraction of alarm area to the total analyzed area. So those things first. We took initial GPS data from a divided geodic laboratory for 2 regions, Japan and California. They consist of type series of daily horizontal displacement of the Earth's surface. Our goal at this stage is to extract a useful signal from the type series and calculate a special temporal fields from which the alarm field will be calculated during training. So Both regions are here on the pictures. The analyzed area marked with a bold black line and black dots mark GPS station. Yellow and red circles are for earthquakes. Yellow that we used for initial learning, and the red ones for testing. There are two differences between these two regions. We choose a start time as we have enough number of GPS stations in use. So there is Japan more likely, and we choose a start magnitude as enough number of earthquakes we have to analyze. There are almost no earthquakes more than with magnitude more than 6 in California region. So let's move on GPS data. This slide is devoted to Japan region and to horizontal component of in west-east directions. So you can see on these pictures, you can see time series on the left side for the whole time range, and on the right, they are zoomed to approximately 1 year. On the first figure, A, you can see the regional data for some point, for some station more correctly. They are very noisy, have a lot of blanks. We interpolate small blanks, but left a big ones, bigger than 30 days. On the B figure, you can see a time series of daily average rate for 30 days. You can refer it as a mean velocity. Both A and B correspond to GPS station located in this point, while C corresponds to the spatial temporal field. We got this field doing special interpolation with an inverse distance weighting function. So the noise level of this field should be smaller than on GPS stations themselves. So on this slide, we have the same time series and fields, but made for north-south direction. The peaks on B and C, and there is this gap on A. There is it's in the year 2011, and it's correspond to the Great Koho earthquake. And you can see there is a big blank in 2013 that in data for one station. It will be filled, it will compensated by a nearby station on the C time series. So on the next two slides, we have made the same technique again, but in California region, absolutely the same. The first slide is for the west-east direction, and the second one for north-south direction. We do the same. We fill small blanks, remove trends, define velocity, and interpolate it in space. See. After that, we have a two-component field of velocity, Vx and Vy. So let me explain the next steps of GPS data preprocessing. We can the first. We compute the invariant fields of a strain rate, divergency field F1, curl rotor field F2, shear field F3. On the next step, we computed the fields of changes of strain rate invariance in time. F4, for example, is more correctly, we calculate student state statistic for each field. For example, F4 is calculated from field F1, and so on. On the third step, we computed the field of special correlation is the change of strain rate invariance. And for example, F7 is a field of special correlation between field F4 and F5. And on the last step, we calculate the field of medium values of special correlation between F8 and F9. In this field, it will be F10. So we've selected for the Japan region the field F10, which is a field of the medium values of the fields F8, F, and F9. And for the California region, we selected fields F4 and F6, which are the fields of changes of strain rates invariance in time. For divergency, for F4, and for the shear F6. So I refer you to our previous work for complete list of fields from seismological data preprocessing. But here I explain the main features. The input data is the seismological catalog. The two first special temporal fields are S1, which is just a field of density of earthquake epicenter, and S2, which is a field of mean earthquake magnitudes. For the analysis, we use the next fields, S7, which is a two-dimensional field of earthquake epicenter's density. This is used for the simple forecast, just alerting the area where earthquakes happened more often. Two-dimensional, not temporal. And S8 is the field of quantiles, shows the quantile of value between all previous value in this point. In our previous work, we selected for earthquake prediction next fields. S9 is just a ratio of S1 to S8 with a small adjustment. And S10 is a negative analysis of students' statistics of the density of earthquake epicenter of field S1. And S11 is the same, the field of negative analysis of students' statistics, but of the mean earthquake magnitudes, field S2. So let's move to the results. On this figure, we have a result for Japan. This red line is represent absolutely random forecast. And this purple line 1 is a special forecast, not temporal. You can see it's quite close to a random one. Line 2 is the forecast that used GPS data only, this yellow line. And it's higher than two-dimensional forecast. Not much, but it's enough to conclude that GPS data can be used for earthquake forecast. Line 3 is a forecast from our previous work that used seismological data only. And line 4 shows the result of the forecast using both GPS and seismological data. It's possible to see that it's quite similar to line 3. But at least it's not worse than the others. That doesn't make it worse. So, but let's move to California region. Again, we have the same lines. Line 1 is a special forecast, and it's also, as usual, is bad. Line 3, this blue line, is a forecast that uses seismological data only. And line 2, yellow lines again, is for the forecast that use GPS data. And you can see that it's higher than the line 3. So that means that forecast based on GPS data is better than forecast based on seismological data. And line 4, green one, it's a forecast using both GPS and seismological data, and it's higher than all others. It means that supplementation seismological data by GPS data is useful, at least in California region. So we've made a video of forecast based on GPS and seismological data in Japan during the time. So alarm zone maps at predicted times t and epicenter of target events with forecast intervals from t to t plus 30 days. The prediction maps are colored according to the average values for the training intervals of the fraction of the alarm zone from the analysis area. So, and earthquakes are shown in red. So we have on the first step we have such alarm area. The more brown, let me return a little bit. So you see, this is the more brown, the higher probability of earthquake happens. So we have quite a big area of alarmed. So let's move next. So this earthquake was predicted. These were also predicted. This was missed, and this was also predicted. It's gone inside area. This was missed. Again missed. And this was predicted, and this was predicted. Missed. Predicted. So we have the same video for California with the same colors, with the same earthquake. with the same drawings. So you can see it's a little bit smaller, have the small area of alarm. So it was predicted. Also predicted. Oh, I suppose it was predicted. This were predicted. This and this three. This was supposed was missed. Yes, it was missed, and this was predicted. And that. So let's back to summary. Let's go. Space geodesy data are effective for systematic earthquake prediction. The quality of earthquake prediction improves if seismological data are supplemented by space geodesy data. The method of area of alarm gives a satisfactory systematic forecast for earthquakes with magnitude more than 6 for Japan and magnitude more than 5.5 for California. The developed information technology for systematic earthquake prediction allows obtain satisfactory earthquake prediction results based on earthquake catalogs and GPS data available on the internet. So, thank you for your attention. If you have any questions, you can ask me.
All right. Thank you for your presentation, Alexander. And thank you for keeping to the time too. Are there any questions about your presentation? I would invite the participants to put up their questions, if there's any.
Yeah, I have a question.
Yes.
Yes.
Please.
I am Vladimir Alarcón. Well, my question is, what would it take to implement this system in Chile? Because in Chile we have also strong seismic activity. So would it be too hard to implement this in a country like Chile? Thank
you. Thank you for your question. I think it's not a bigger problem. The main problem that we that as you can see, as you can see, the main problem is that we have no data from GPS station. But we can use yes. If we can found GPS data for Chile, it will be very easy to implement. It's not a problem. We do it for 2 regions. We can make it for several regions. It's not a problem at all. But the main problem is to get data from GPS. Of course, we can implement this system without GPS. But as you can see, there is much more. This forecast is much better if we use GPS data, especially in the region such as California or Chile. Moving there is when there is falls inside on the earth or not in the sea.
Mm-hmm.
So,
all right, thank you. Can I add a brief other question? From what I gather from your presentation, there is my question: is this still an experimental system, or is it in any way operational?
It's it's experimental system, but we try to make it an operation, so it's working. Right. Let me show. Let me show. So yes, we're just trying to. There is result.
Yeah.
There is working just for Japan, so it's trying to update automatically, but we're still working on it. So, for example, you can see there is like on a public website, it's working. Trying to find. There is so It's still experimental, but
Okay.
it's also public in public access.
Yes. Thank you very much. Any more questions for that presentation? That does not seem to be the case. We have to move on anyway. So I call on the second presentation, which has the title Survey of a Peruvian Archaeological Site Using Photogrammetry and LiDAR, a contribution to the study of the Chachapoya. And presenting will be one of the following persons: Gabriele Garnero, Giovanni Righetti, Stefano Serafini, Fabian Brondi Rueda, and Warren Church. Now, who's going to present?
No, there isn't.
Is no one there?
No.
Oh, all right.
The next.
Any chance that the guys will turn up later? Obviously, no, huh?
I don't know.
All right, so then we move to the next presentation, and I know the presenter is there. It is the title is Estimation of Hourly Salinity Concentrations Using an Artificial Neural Network, and the presenter will be Vladimir Alarcon, with his co-authors Anna Linhos, Christopher Kelbley, Paul Mickley, Joseph Bishop, and Emily Milton. Right. So we can see what we are going to expect, and the floor is yours, Vladimir. Please go ahead.
Thank you very much. Yes, I am going to present a collaborative work between my university, Universidad Diego Portales, and Auburn University, the Ocean and Atmospheric Administration of the United States of America. And it's about estimating hourly salinity concentrations using an artificial neural network. I'll give a brief background on Biscayne Bay and, and the surrounding area to Biscayne Bay. I will highlight the traditional modeling approach and the limitations that we had with the traditional modeling approach of salinity. And that's the justification for applying neural networks to try to estimate better salinity in coastal Biscayne Bay. Biscayne Bay is located in the southern tip of Florida. It's a bay. It's a 13,000 square kilometer bay. It's a big bay, and as you can see, during the recent decades, the surrounding area to Biscayne Bay have been intensively urbanized, and with that, of course, many problems arose. The area, I am showing here a characteristic watershed draining to Biscayne Bay. The area is highly urbanized, as I said, and because it has been intervened by several waterways, man-made waterways and man-made canals, also hydraulic structures that modify the surface flow, the predominant use of septic tanks in the area, etc., have created several modifications to the natural flow of waters to the bay. The area is very flat. Slopes are between 1% to 5%. And most important, soils are of a karstic nature throughout the study area. So soils are a very difficult type of soil to model because, for example, the seas law does not hold in this type of soils, etc. And again, land use is predominantly residential and commercial, and of course, the increase in populations have increased the modifications to the natural flow and also the contamination of waters that go to the bay. So what we wanted to do is to try to estimate the salinity distribution in Biscayne Bay. And of course, first we had to develop a hydrodynamic model, and we used EFDC for developing this hydrodynamic model. And the modeling was straightforward. It didn't present a lot of difficulties because we counted with a lot of information, not only bathymetric and topographical, but also tidal data to validate and to calibrate and validate our model. We've included several streams that drain into the bay, including the hydraulic structures that those streams have. And as I said, for example, the calibration was without any surprise. Our hydrodynamic model replicated observed data very well. The statistical indicators actually showed that. And also during validation, we had the same response. We had good statistical indicators. And again, I am showing here only 1 year of simulation, but we've simulated from 2012 up to 2019. So it was an extended hydrodynamic modeling and simulation at an hourly rate, an hourly time step, and we didn't have any troubles. So we were expecting to have a fairly easy modeling process for estimating salinity. And we've implemented the boundary conditions, implemented other interesting features that Biscayne Bay have, and we were getting very good simulations for salinity stations that are offshore. But for salinity stations that are located near the coast, our statistical indicators were not very good. So, for example, in the northern part of the bay, we have that kind of behavior. We captured very well the salinity at the offshore locations, but when we go close to the coast, our statistical indicators were not very good, because if you observe here the blue line shows the observed data. The red line shows the modeled, the simulated data. And our model was not able to capture these minimum salinity concentrations that in some locations go up to almost zero salinity. We tried several ways of improving these results, but we couldn't improve them with the traditional way of capturing salinity. So we had the problem that the coastal locations, to which also we are very interested on, we couldn't get salinity concentrations as they were observed. So it seems to be that the traditional hydrodynamics and salinity modeling effort wasn't working. Of course, this had to be related with groundwater inputs that our model was not taking into account. Also, the karst terrain that produces preferential flow paths that dominate the very fast transport of groundwater to the bay. We also didn't have groundwater data, and we don't know the specific characteristics of karst soil in the mainland. We wanted to use, for example, mud flow to model the groundwater contribution to the bay, but since we don't have enough data, we cannot generate a good model. So artificial neural networks seem to be an interesting alternative, and we tried it. Of course, we had to analyze all the observed data that we had. For example, in this slide, we see we are showing the cumulative precipitation in the area, the salinity. One of the stations that showed more variability in salinity was station VISC Z4. And also we are showing the flow that comes in a creek that drains near the point in which we are comparing or we are analyzing salinity. We are also showing the salinity at the boundary, because this is our ocean boundary when we've imposed salinity concentrations that were measured close to the ocean. So doing this kind of analysis, we've selected the most useful variables to try to estimate salinity more accurately. And we used an autoregressive artificial neural network with exogenous inputs. We trained the network in an open loop architecture, and of course for forecasting we used a closed loop architecture. We accepted the default algorithm for training, the Bayesian regularization, and after playing with several configurations of the artificial neural network, we've come up with a good training of the network with good statistical indicators. But as you know, training is just the first step to apply an artificial neural network. The forecasting phase is a little bit more difficult because we wanted to use independent data to forecast our the salinity at this station. We use several statistical indicators, and our forecasting strategy consisted on, of course, training the network with 2 years, 2013 and 2014, and then begin using the predicted output produced by the artificial neural network from 2014 to 2015 on. And the last years, we predicted just based on the predicted outcomes by the artificial neural networks. I want to remark that these are hourly salinity concentrations forecasting. As you know, the smaller the time step, the more difficult it is to capture the dynamics of any modeling effort. And our results showed that our artificial neural network produces good estimations, better than the estimations of the hydrodynamic and salinity model, the traditional hydrodynamic and salinity model, because as you can see, the orange line captures up to some point, of course with some limitations, the lower concentration values at the station that we were analyzing. Our statistical indicators were good. So just in conclusion, we can say that using this type of artificial neural network, we have successfully simulated concentrations of salinity at an hourly time step for 5 years. And the statistical indicators showed us that the simulations are good, and our neural network captured the salinity minimums that the traditional way of modeling and simulating salinity didn't capture. And we are using currently this neural network to estimate groundwater contributions to the bay, and it is proving to be very handy, and that's a research that we plan to present perhaps in the next version of ICCSA. With that, I finish my presentations, and I will welcome your questions.
Yes, thank you very much.
Please switch on your microphone. Please switch on your microphone.
Can you hear me? Someone muted my microphone. Vladimir?
Are you talking to me?
Yes. Someone muted my microphone, so you didn't get me.
Okay.
I just had one question regarding to the conclusions that you made. You said they were quite useful, the estimations that you did using artificial neural networks. Could you say anything about the precision of these estimations in relation to existing data? Though I got your point that there are not too much data existing. Am I right?
Well, we actually have observed data, but as your question, in this table I am showing the comparison of the artificial neural network model, the quality of the artificial neural model, and the quality of the
data taken,
estimations using the traditional ways. And as you can see, for most of the statistical indicators, our model performs well, while the traditional way had several problems. For example, a bias, a very big bias, 22%. It has this Nash-Sutcliffe efficiency coefficient negative. That's not very good. We got 0.33. It's not ideal, but it's positive, and it shows that the model works. Of course, our Klein-Gupta indicator is very good, 0.64, while the hydrodynamic model is only 0.33. So it's our artificial neural network model is modeling salinity and forecasting salinity acceptably.
Yeah, pretty well. Yeah. All right. Thank you for clarifying that. Any more questions for that presentation? All right. I hear no one posing a question. So again, thank you for your presentation, Vladimir. And now we come to the next presentation, which I believe is our last presentation, if our second presenters have not turned up yet. Before we have had presentations of collaboratory works, and now we have the presentation of one colleague, who presents on a very up-to-date topic that we all are suffering from. His title is Tracing and Modeling of the COVID-19 Pandemic Infections in Poland Using Spatial Interaction Models, and the presenter is Piotr Werner of the University of Warsaw. Piotr, please, the floor is yours.
Thank you. Can you see the presentation?
Yes.
Okay. I'll make a change to presenter. One moment. Something happened. Okay. And now you can see. Okay.
Yeah.
So
please go ahead.
Thank you. The roots of this project is there that I was dealing with spatial interactions model from almost the beginning of my geographic career, but the triggers are Nicholas' essay on metaphor of black swan in white card, and another trigger was well-known Donald Trump's dilemma. You can find it in everywhere, even in Wikipedia. There are known nouns, there are things we know. We also know that there are known unknowns. And I can say that COVID-19 is known unknown, I think. There was an interdisciplinary research project in response to Polish National Research Center call, and the reviewers assessed the project patronizingly with indulgence, and it was rejected. Then we rearranged the internal structure. I was stubborn and joined to a group of researchers in Warsaw University of Technology and try to convince them that it could work. The report and the presentation shows the intermediate result as February 2021, but some findings were updated in this presentation. I will show you later. So the spread of infections, this is inherently a spatial process. Therefore, geospatial data, technologies, and analytical methods play a critical role, in my opinion, but not only in my opinion, in understanding and responding to the coronavirus disease. Policymakers, scientists, and journalists agree that one of the key issues of effective combat against global pandemic is tracing statistics. Yeah. I mean observations of the number, intensity, and spatial variation of disease status, infections. These are words of Jack Dangermond. The nexus of factors influencing the dissemination of SARS-CoV-2 pandemic is so complex, in my opinion, that identification of some determining factors of COVID-19 spatial diffusion is significantly hampered. There were trials to show the spatial diffusion of this pandemic in Poland, but it doesn't work. It shall be deemed that COVID-19 characterizes a specific dynamics and is far more transmissive. I think that aims of the study is the construction of the model of spatial dissemination of COVID-19 in Poland, but I was dealing also with our neighborhood countries. But for the moment, I will present the data for Poland. Identification of main outbreak places and spatial heterogeneity of pandemic based on spatial set of first-year morbidity data in 2020 in Poland. The target prototypical model in its core is intended rather as the supporting tool than the replacement of the well-known and used suspected, infected, recovered, or SARE models in epidemiology. This is a supporting tool, I think. It also assumed that the target model could be used as a priori estimation tool of the spatial location of infection outbreaks. This is a number of infections summed up from 4th of March 2020 up to 1st of August this year. And then we can, oh my God, there it is. So this is the main the diagram presents cases over time, monotonic increasing complemented recovered data. I used COV-CRI Python application, which authorized by Guidotti D'Angelo, and it is available online. But I must say that there are a lot of efforts to to make the line of the infected and the line of fatal cases to be minimalized. This is the diagram which presents the cumulative number of infections by 380 counties in Poland. I used simple LibreOffice spreadsheet to present it. This is up to 35 weekend of this year from almost the beginning. As you can see, there are moderate waves which we perceived earlier as great, but later there was too much, and now in summer it was a little bit hampered, a little bit smaller. The theoretical foundations are the model of spatial interactions, two of them. Of course, there are family of spatial interactions model, but I've chosen unconstrained gravity and destination constrained. These grayed rows are data concerning infections in counties, and this double sum sign the total number in Poland. Of course, there is a distance matrix because this was the metaphor of the well-known mathematical model counting the number of handshakes. I mean, I tried to model contacts. So the results of this are very promising, because in the first weeks of the pandemic in Poland, there was a small coefficient of determinations, but later it was worked, and it was almost 85%. The application is also to be found. It is authorized by Ocean, and it is available. I've made small changes. So these 85% as coefficients of determination can be interpreted as 85% of real number infections. So this is the cartographical presentation of and visualization for 2 weeks in February, and this is really a little bit different. I don't know if you can see the detailed numbers, but about 15% they are lower than the real. So I tried to a priori simulated the models a week ahead for the 7 based on the 6th week. I tried also to encapsulate and to sum up the different time intervals, few weeks, and taking into account for modeling these different time intervals, the same similar values were obtained. So what can I say? When we have a SIRF model or SIR model, we have the total number in Poland. Then we can try to really evaluate the real number of infected, a little bit lower than can be really in this moment. What are the next steps? Because it is this nexus of different factors, we can try, and we are in the moment try to. Sorry, time is out. Please give me 15 seconds. This is one of the. So we can try to make a simulation of Monte Carlo. This is an ongoing research now, because the unexpected nexus, for example, different political, healthcare systems, and some other factors can modify it. Then we can try to modify input variables. The input variables was the number of population, but we can successively subtract the vaccinated people and recovered people from the number of as the input for the modeling. Then we can try to use a demographic stratification of contacts. And last but not least, I try to make a little bit Zoom. Oh, sorry.
Yeah.
Zoom. No.
Yeah, go back. Right.
Can you see here?
Yes, we can see that.
This is my last finding, that this is not a good news, because the temperature is correlated with number of infections negatively with almost value with almost 0.7. So there could be the next wave. Thank you for your attention. If you find the presented approach relevant and suitable to form wider research against COVID, please let us know. This is a group of us. I'm only presented because we are working on different lines. I'm presenting, I'm stubborn on this model, so that's why I'm here. But there is a group. We are ready to join or to form the new interdisciplinary research in the wider group. Thank you very much.
Yes, thank you very much, Piotr, for your presentation. And again, the floor is up, is available for questions now. Any question to that presentation? Okay. So it's my question then, Piotr. I would like to ask you, as we have seen, at least in our part of the world, but I guess globally, around this COVID pandemic, there has been so much modeling of all parameters. You have concentrated on the spatial side of this modeling. Now, my question would be, do the politicians in charge use any of your findings?
I must say,
Do they know that? Are they interested at all?
I hope they know, because this is part of the wider project, which is reported to
You
Warsaw
mentioned that.
University of Technology.
Mhm.
And there will be another paper which has been sent to a well-known journal.
Mhm.
And I know that the head of this project reported the results, intermediate results, and ongoing results. And I was perceived that I am a little bit stubborn on this spatial aspect, but on the other side, when I was talking with him about the temperature, he told me that this is not true, but I was not a little bit convinced that he is right. So I really make a little pilot study and found that this is really, and this is the subject for another research.
Yes, this is a different project.
Yes.
Mhm.
So this
Thank
is,
you very much.
thank you.
Any more questions? I hear there are no more questions. And so thank you again, Piotr. This is my last call. If anyone of the presenters of the second paper, this survey of Peruvian archaeological site, have been turning up by any chance right now? This does not seem to be the case. All right, so we're well on time. Thank you very much for all the presenters, for keeping to the time, for allowing questions. I think we've had interesting topics that we have been have been presented right now. So thank you very much for the presenters. Thank you much for the other visitors of this session who have attended. This is the end of the first GeoAnMod session. And before saying thank you, I would like to refer you to the next sessions. There are 2 more GeoAnMod sessions, each after a short break. So in about 15 minutes time, and we give it a Mediterranean few minutes, the next GeoAnMod session will commence, and we have the third and final session of about 5:45. So I hope I'll all see you there. Thank you again, all of you. It's been a pleasure to chair this session. Let's hope there is a chance next year not only to meet virtually, but also to meet personally. So with that wish, thank you again, and have a good time during the conference, wherever you are and whatever you do. Thank you.
Thank you, Helmut. Look forward to see you next year.
Yes, inshallah. Bye-bye. Thank you.
Bye-bye.
Bye-bye.
Bye-bye. See you next year.
See
Bye-bye.
you.
Streaming is on.
Buongiorno, mi sentite? Giusto per capire. So che non abbiamo ancora iniziato la riunione, però vorrei capire se perlomeno l'audio è attivato.
Sì, è attivato l'audio.
Benissimo, grazie.
Siamo tra pochissimo.
Sì, posso adesso disattivo sia la telecamera che l'audio, così so almeno che siamo sono giusto corretta. Ok, grazie.
Mille.
Streaming is
Ciao Gabriele.
Ciao Giuseppe. Aspetta che disattiviamo.
Se volete che lo schermo, faccio questo.
Provo a mettere in condivisione il schermo così vediamo se funziona. Tanto che aspettiamo.
Ok.
Così mi dite come va?
Ottimo.
Bene, ottimo. Adesso quando poi si comincia mi dici.
Ok. Se esci un attimo così intanto faccio una...
Mhm.
Chiudi un attimo.
Aspetta, torno indietro, interrompo condivisione. Eccoci qua, solo un attimo. Spero che abbia interrotto. Oh, là. Eccomi.
Ok. Condiviso il nostro, no? Come funziona? Aspetta. No, aiuto, cosa ho fatto? Cosa ho fatto? Ma danni? No. Aiuto.
Perché se vi guardate tutto qui, annulla.
Mi metti solo in... Bella effetto. Spento il microfono. Ok.
Right. All right. Hi, Giuseppe. He's muted.
Okay. Maybe we had some short technical issue because I think that our mic were mute, so I spoke to myself and to the people that are here in the room. So sorry for that, but this is some technical aspect that we didn't actually manage in 1 year and a half of online presentation. So my apologies for that. So welcome to everybody here, both in presence and online, to this geographical analysis urban model spatial statistics session within ICCSA conference. We have 4 presentations this afternoon, and the first presentation will be by Gabriela Scheuer, from my home university, from the University of Trieste, and I will give her the word. Thanking all of you for participating to this conference this year, and anticipating you that the extended version of the papers presented here could be hosted by a special issue of the International Journal of Geographic Information. And the details will be given to you after the conference in order to incentivize you to send some more paper for publication. Thank you again, and Gabriela, let's say that we have more or less 12 minutes for the presentation, allowing some more minutes for Q&A or whatever.
Okay, just a moment. I just
is on.
to propose a possible solution to the problem of urban Italian mobility, but the methodology in question, multiple factor analysis, MFA, I think may be used in different situations. So I think this is interesting because it's a multivariate method used for trying to aggregate the possible solutions, for instance, of how to describe sustainability of urban Italian mobility, but also other different problems in using some different methodology.
Gabriela, you should share the screen.
You can see this no, or not? No. Now you can see.
Not yet.
Not yet. Hello. Okay. Just a moment. I try again. Just before yes, now not. Probably I try again. Okay. Try again. Just a moment. Now it's okay?
Yes.
Yes, okay. Allora I just try again. I don't Okay, the aim of this paper, I just start again. The aim of this paper is to analyze the sustainability of urban transport of Italian provinces. We use a methodology usually applied in statistical, multivariate statistical, which is multiple factor analysis. This is interesting because this type of methodologies can allow to use both quantitative and qualitative variables together. This is really very interesting. After just to give an idea of this multiple factor analysis, then we use a definition of sustainable mobility, and then we consider some indicators to measure this aspect, and then we just have a look to some results of the applied analysis. So MFA is interesting because you can have a matrix, different individuals, for instance, like in this case, provinces. Okay, provinces are the units, and then you have some variables. So one column, one variable, one row, one individual, for instance, one province. So the fundamental idea, like is written here, lies in the fact that within the active variables, because you can have different variables observed on the individuals, for instance, on the provinces, but perhaps you can say some variables are not important for using in my particular problem. So the fundamental idea is to use active variables and account, as it is written here, the fundamental idea lies in the fact that within the active variables, it can account for a group of structure defined by the user. So I have some variables which for me are important. I can divide these variables into groups, and according to these groups, the importance of this variable may vary. This is interesting. Such data tables are called individuals by variables organized into groups. Okay, so this algorithm is a mixture between PCA, principal component analysis, for quantitative variables, and multiple correspondence analysis for qualitative variables. So the idea is that you have your set of variables, units on which these variables are registered, and you can obtain the subgroups of variables that you can measure in different way. You can weight in different way. As in this case, you can do, okay, according for me, economic variables are more important than environmental variables, for instance. So you can just aggregate and weight these variables. So you compute a PCA of each data table, and you have to normalize them. If one knows this particular multivariate statistical analysis, know that you have to normalize them in order that the variance doesn't go to infinity, and so the variance is the singular value. In this case, the greatest variable is the first singular value. So you compute a PCA, normalize them by dividing all elements that the first singular value obtain, and then you consider a new PCA, and this allows you to obtain the so-called dimensions or axes or factors or latent variables. Now this is interesting because we can go on just to understand better this idea. The definition of sustainable mobility that we used is according to that proposed by the European Conference of Ministers of Transport. And so some three ideas or three concepts, allowing the basic access and development needs of individuals, companies, and society, so to meet safely and in manner consistent with human ecosystem health and promote equity between successive generations, being affordable, operating fairly and efficiently, offering a choice of transport models supporting competitive economy as well as balanced regional development, limiting emissions and waste. This is the definition we used in order to construct our indicators. Indicators, obviously, there are different possibilities. This is just one possible choice. Everyone who wants to give us some new idea is welcome. According to the three basic economy, environment, and society, we consider for economy wellness, salary, employment. If you want, you have the paper, and you can see in details what we will use in this paper. Environment, gasoline fuel, diesel fuel, low emission, e-charging station, PM10, urban green. These are the indicators as regards environment. And then for society, fatal accident, pedestrian deaths, population, and vehicles. We consider Italian data at provincial level. 2019, the data we used, unless for wellness 2016 and salary 2017. And this here there is the organization of the data. So the variables considered in this study are structured in 6 macro groups, because if you remember, we see individuals, variables, aggregated according groups. And this is a choice, obviously. Different choice may be used. Just some results. So, multiple factor analysis follows a PCA analysis, principal component analysis. So the main idea is to aggregate the variables in new variables called, in this case, dimensions, 2 or 3. In this case, 2 is, according to me, sufficient, because it's follow. If you just follow the graph, you can see that the percentage of explained variance by looking at the script plot is more or less 59%. So the new variable, in a certain sense, the new variables explained almost 59% of the variance of our as we say, of our problems. And this is important because the variance explained say that more or less the 60% of the original problem may be explained by these new two dimensions, two variables. And so you can have, in a certain sense, an aggregation and the possibility of explaining the problem using only two dimensions. Let me see. Oh, so just a moment. We'll play. If you just this. The important thing of this analysis is that, according to me, you can have immediate representation, visual representation, and this may be useful also in a big data problem, in big data problems, so not in ours. But for instance, in this case, you can see that you have a quantitative. You have to look at quantitative variables, and in particular, you can see two dimensions.
Gabriella, we should go towards the conclusions.
Okay. Just one moment, Giuseppe. Just one moment. The first dimension represents the economic part and the vehicles in the provinces, and the second dimension represents the social and environmental part. So we can see just from this that if you have the structure of the variables are positively correlated with the first dimension, you can see in the first part of the slides. And so you can have directly the idea of which variables, original variables, might be explained by the new variables. So, and but this, okay, I just go on because this is you can have a look, and this may be interesting also in other applications because you can see units by units what's happened. So conclusions. We try to analyze urban transport mobilities at the province level in Italy using MFA procedure. One of the advantage of this for analyzing this complex phenomenon is that it allows to catch the aspect of the direction magnitude relative to the set of variables representing the various dimensions regarding units, such as in the case of Italian provinces. Eccolo. So, I think that this may be interesting not only in our case, but also in all other situations and other possibilities. So, this methodology, according to me, my co-author, may be useful also for other people. Thank you for the attention and sorry for the delay.
Okay, thank you very much. Thank you for your presentation. Interesting piece of presentation. Actually, it is worth to analyze more in depth the different clusters coming out from the analysis, observing the different behaviors of the different provinces at territorial level. That would be a promising piece of research. Okay, thank you, Gabriella. Thank you very much. We'll leave some time at the end of the session to see if there are some questions. Okay, I'll ask you if you can exit from the sharing of the screen, and I will ask Valentina Santarciero, that is here, to come along and do her presentation. Okay. Okay, so Valentina is presenting this afternoon her first, she'll be actually one of the pre-presentations that she will having this afternoon. I think she's going to start with remote sensing and geostatistical approaches to mapping urban areas in Apulia region. And Valentina, it's okay.
Okay, thank you very much. Good afternoon, everybody. My name is Valentina Santarciero, second year PhD of University of Basilicata and CNR MA of Tito Scalo. The first work that I will present to you this afternoon concerns the statistical approach and the use of remote sensing in order to quantify and mapping the burned areas in Apulia region, in southern part of Italy. Every year, forest fire affect a wide areas in the world and cause devastating damage at a global scale. Forest fire represent an environmental problem and generates negative impact on the forest system and alter the structure of vegetation and soil. So, fair danger estimation is very important in order to quantify the impact of this event on landscape and play an important role in the framework programs for mitigation, provide a very important information about the degree of degradation. And assessing and mapping the fire severity and the burn severity is very important to quantify and monitoring the effects of the fire in order to evaluate the post-fire dynamics and to estimate the ability of vegetation to recover after the fires, generally indicated as a fire resilience. The aim of this work is try to implement an automatic processing tool in order to map the burned areas. This work proposed a procedure that analyzed and detects the change detection of the potential burned areas using as a Sentinel-2 data and a geostatistical approach in a GIS open source environment. In order to implement the detection of the burned areas, a graphical model has been developed. The study areas were carried out in the northern part of Apulia region in Foggia prefecture, which present an increasing of number of fire events generally occurred in the summer period. The reference period for this work is the period between July and August 2020. The area is characterized by grasslands, coniferous, and agricultural land, and the climate is typical of Mediterranean area. This study area was selected first because represents the Mediterranean area, and also because it's an interesting test case for the wildfire occurrence into Mediterranean basin, because Apulia region is one of the Italian regions affected every year by a lot of incendiary phenomenon. After fire events, the spectral behavior of vegetation change. In order to quantify this change, we used the normalized burn ratio. This index has been estimated using the Sentinel bands most sensitive to the change in the post-fire reflectance value. Maps obtained by difference between NBR pre and post-fire indexing, called the Delta NBR index, provide a measure of change which can be used to estimate the fire severity. This image represents one of our results. In order to assess the fire severity degree, this raster has been categorized and classified in 6 classes, from unburned to very high burned. In order to exclude false positive pixel not otherwise recognized, after the calculation of delta NBR, this raster has been corrected with 4 masks. The first one is cloud mask, shadow mask, water mask, and agriculture area mask, because we are interested to evaluate only the forest fire. After that, we applying a threshold of delta NBR more than 0.1, and the threshold of 0.1 is the value that we used to discriminate the area burned or from the unburned. After that, of the delta NBR, after the mask of this delta NBR mask, we applied the local spatial statistics interpretation. In this case, we used Getty's-Edwards interpretation with the aim to identify the cluster of similar or dissimilar values. The application of spatial autocorrelation statistics to remotely sensed images allow us to obtain a new raster that contains in each pixel a number that expresses how much is correlated to another pixel. This model is called fire area detection model, and used this for the determination of fire severity. After that, this map was subsequently implemented in QGIS environment, which involved identifying the areas covered by the fire, starting from the binary map obtained from the application of autospatial correlation methods to the ICCSA map, and from the delta NBR map obtained from the masking procedure. In conclusion, by applying this methodology, it was possible to identify in the analyzed areas that the born areas occupy in total one surface about 5 square kilometers. And a comparison with the true and false colors images, and also with pre- and post-fire NBR images, clearly suggests that the identified areas are correctly classified as a born area, and as a born area are connected to the presence of the fire. In conclusion, the application of this model allow a quick and easy identification and perimeter of the burned areas. This model provides a tool that we can, in order to estimate a real perimeter of the fire, and it represents also a useful land management tool for the spatial planning. Thanks.
Okay, thank you, Valentina. Thank you for your presentation. Just a short question. Do you have any plan to extend this study over, apart from this study area that you consider in Puglia region, to other parts of Puglia region or other parts of Italy?
Yes, we choose for this study, we choose the Gargano area because in Puglia region is a region that we have a lot of forests. And we want to try and validate this model in other parts of Italy, where we have a lot of presence of fire and a lot of presence of forests, like Basilicata, like Trentino, and other one.
Could be an idea to test it on Sardinia region as well, that has a quite...
or Sardinia for...
That brings my question. Here, various areas are mapped, and the map is validated by the military corps.
Yeah.
So it could be an idea for you to validate your models by comparing the outcomes of your model with the verified data, because it's certificated and you can download it everything.
Yes, the second step of this study is match our data derived by application of this model of the satellite images with the images with the data that are obtained from Corpo Carabinieri Forestali dello Stato, and we last month we obtained this data from Puglia region and the period that we analyzed this, and future work will be concerned to the match of these two data in order to verify this work. We hope that our work is verified.
Okay. Another question. I have to ask you if you come closer to the mic, so you can be heard. If you can come closer.
There's a terza.
No.
At the same time.
Non si sente. Sì, no.
Yes, my question is, which tool did you use for the data processing?
I don't understand the last part of your question.
Yeah, which tool did you use for the data processing, for the image processing?
Only in QGIS environment. We analyze satellite images using raster calculator and the plugins present on QGIS environment like SCP.
Yeah,
And in order for the masking of the satellite images, we use the threshold, the value of threshold present in bibliography, and we apply the map algebra.
Yeah, and the second question, is the processing like time demanding? How long like is the computation? For example, if you downlink the static images, and which time do you need for the data processing? Like hours, weeks, days?
Also, this model is automatic.
Yeah.
And we introduce all processes that we created in a graphical modeler in QGIS. For this reason, in 1 day, you can analyze 2 data. When I say 2 data, I explain the data pre-file and the data of post-file. Like 1 data of the 1 images of 2 images of July and 2 images of August. So in 1 data or 2 data, we can apply this methodology. It's very fast.
Yeah, fast. Okay. Thank you.
Thank you.
Thank you, Valentina. I think that you can stay there because
Yes.
we got another presentation. Soil erosion and degradation in rural environment, preliminary GIS and remote sense approach.
There are a message. I cannot see the presentation.
Okay, but it was.
Okay. Oh, not this. I'm sorry, not this. It's this.
If you. Okay.
Okay. Can you see my presentation? Okay. So, good afternoon again. The second work that I will show you explain the soil erosion and land degradation in rural environment, a preliminary GIS and remote sensing approach.
Is on.
Perlomeno hanno avuto la possibilità.
Okay, so nowadays land degradation is one of the problems that causes a major consequence from environmental point of view. In general terms, land degradation is a process driven by a combination of different causes, like the presence of fire, the fragmentation, the land use change, the loss of ecosystem services. In this work, we analyze the soil erosion phenomenon. Soil erosion is due to, in particular, to the intensity of rainfall. In fact, when a short intense rainfall affects soil without vegetation cover, the runoff removes the surface layer rich in organic matter from the soil. The causes of this process are different, but some are related to the agricultural activity. In fact, the agricultural overexploitation and land abandonment are leading to the alteration of ecological level. The aim of this work was to relate erosion data to land cover in order to try to evaluate how this process may influence the degradation phenomena and the relationship between the abandonment of rural agricultural activities. The data set used in this work was consistent of the use of Marine Land Cover Map, Nature Map of ISPRA, the orthophotos by AGEA, and the Sentinel-2A and 2B images. These analyses were performed in a small area of Basilicata region, including 17 municipalities. As I show in this picture, the actual area does not include the real perimeter of the municipalities, but it has been cropped on the basis of the satellite Sentinel images what used. This area is characterized by a Mediterranean climate with a pronounced seasonal regime, with a hot and dry summer and cold and humid winters. The first part of this work involved the implementation methodology useful for estimating and mapping areas with high erosion rates. The preliminary investigation was based on zonal statistics on average monthly and annual values with respect to the area with arable land and post-cultivation vegetation area, also called abandoned area. The integration of satellite images and statistical analysis is an innovative approach for analysis and mapping based on factors influenced by the spatial and geographic components. The issue of auto-spatial correlation is fundamental to assess a phenomenon particularly intense in a specific area. In the present work, the autocorrelation index were applied to the Ruslen model in order to produce a persistent erosion map. The Ruslen method is based on 5 variables related to the precipitation regime, soil properties, topography, crop cover management, and conservation cropping practice. The result is an estimate of the amount of soil due to the surface erosion and erosion of the field, annual soil loss, and in this case also monthly soil loss. In this slide, we assume that only for the month of March, the input factor of Ruslen method. In fact, the first month is referred to air factor equation that is based on the rainfall intensity development in Basilicata. We also have the soil erodibility factor called kappa factor, and that represented the rate of soil loss per unit of precipitation erosion index, and is derived from a pedological map of Basilicata region and from the Basilicata region soil database. C factor is calculated using satellite images in order to consider the impact of vegetation cover on erosion. The factor P is considered the effects on agricultural practice carried out to mitigate effect of the rainfall, and LS factor is concerned to the topography. These slides reassume the value of a factor that represent the monthly soil loss with applied Ruslen method. After that, the statistical interpretation of the index is applied to the Ruslen result on the basis of outspot, the pixel value rather than the mean. The index was applied individually to each mount, point out on only the pixel with positive autocorrelation, and then subsequently was cumulated into a final raster called persistent erosion map. That this is a persistent erosion map. The statistical operation performed with the Gettys or the interpretation allowed for the creation of this map. This binary map have only two values, 0 and 1. The areas of interest are those that have value indicated with 1, that represent a constant erosion contribution during all months for analysis. And in the end, from the evaluation of the arable land classes, it can be seen that the amount which the highest value are present in November. This is due to the amount of rainfall and to the fact that in November is the month with the arable land don't have a vegetation cover. It's more useful to investigate arable land in March because in March the vegetation have the maximum value. Considering the areas of post-cultivation, or also called abandoned, it can be seen that the months of greatest value are also, in this case, November and March. In March, the average value in the abandoned areas is almost double, probably due to the fact in this month the arable land are already provides a ground cover. So this preliminary study, preliminary because we analyze only 1 year, provide a useful information for spatial decision support system to identify areas and that are more vulnerable and need further analysis and monitoring. The integration of satellite images and statistical analysis is an innovative approach for analysis and mapping based on the factors influenced by the spatial and the geographic component. Thank you.
Okay, thank you, Valentina. Thank you very much also for this presentation. Is there any question? Any request for?
I have two questions.
Yes.
The first has to do with the key index of the management one in the rule question. So the question is, how did you get that?
How did
we calculate that?
We use the data present of we use the data present of the pedological map of Basilicata and used the bibliography data. We don't calculate the P factor. We also calculate the R factor and the C factor. R factor, for R factor, the runoff, we calculated this, applied a equation, and okay.
My question was only
okay.
And the second question is about the Gettys or the calculation. To my understanding, it estimates hotspots based on whether in a certain point the value is systematically higher than the surrounding one. So why did you choose that? I mean, it doesn't produce a map of high values, but it looks at a value in the surrounding area.
Okay, we applied with try different spatial autocorrelation index and interpretation. We obtained the better data that we obtained, and the realistic data that we obtained are referred to the output obtained with application of Gettys or the interpretation. And The map of gathers and obtained is referred to the higher value of erosion. With the, we apply this interpretation only to the value month per month, and we indicate the area that shows a persistent erosion value, the higher persistent erosion value every month. I am not sure that you are.
Maybe we'll comment on that afterwards.
Okay.
Thank you.
Okay. Thank you again, Valentina.
Okay.
Last but not least, I will move to our last presentation given by Valentina as a presenter and as in charge of a wider research group. More sense methodology assess the abundant arable land using NDVI index in Basilicata region. Okay. Again.
Thank you again.
Take some breath, take some air.
Okay, 1 minute.
Take some water. When you like, you can start and
okay.
Your presentation.
Okay, thank you very much.
Trained at this point.
Thank you very much. So in this work, we analyzed the historical trend of NDVI index in order to assess quantifying the abandoned arable land in Basilicata region. As I told you in the previous work, the causes of land degradation are different. In this case, for this work, we try to analyze the land use change and in specific case, the land abandonment. Land use change is simply refers to the conversion of a part of lands purpose to another. And land abandonment definition concerns of the land that was previously used for crop or pasture, but does not have farming function and has not been converted into forest or artificial areas. The European Commission assessed that in the period between 1915 and 1914, about 11% of agricultural land is under a high risk of abandonment, which has a strong and no environmental and socio-economic consequence like soil erosion and desertification. The data set used for this work is similar from the previous, but in this case we not use the Sentinel data, but we use the Landsat, different Landsat data in order to calculate the historical series of NDVI. We also use different data of orthophotos in order to try and apply the photo interpretation. And we also use the agricultural census data. The study area is the same study area as analyzed in the previous work. We choose these areas because this part of Basilicata region is particularly vulnerable to the phenomenon of the abandoned land due to the combination of anthropogenic and natural factors. Analyzing the colonial land cover map, it can be seen that this area is mainly occupied by agricultural areas. The aim of this work is to try to evaluate, identify the area subjected to phenomena of crop abandonment and or agricultural transition in the period 1909-2020. A first step is in identifying these areas involving the use of the normalized difference vegetation index, also called NDVI. NDVI is an indicator that provides the vegetation health status based on the leaves reflectance. To create a realistic phenological curve, it has been assumed that the arable crops have annual cyclicality, where we find a maximum NDVI value in the spring periods, in the months like March or April, and the minimum in the autumn, like period of October and November. After calculating the NDVI difference for each year, the next step was to discriminate the images related to each single year through change detection analysis. The values of the value of difference NDVI of probable land areas from the all other values. We assume that the NDVI threshold is greater than 0.5. We use this threshold on single images in order to discriminate the probably arable land to the other. After that, we obtained the delta NDVI arable land from each year from 1990 to 2020. After that, with map algebra and different steps, we obtained a binary NDVI arable land that reassume the pixel indicated with the value 1 arable land during all the 30 years, with 0 not arable land during all the historical period. After that, we match these images with the change detection analysis and match with the nature map of ISPRA. And we obtained two different maps. One of related with the natural vegetation in according of the classes of ISPRA, nature map of ISPRA, and the second one related to only to the agricultural areas. So, okay. After that, with map algebra algorithm, we divided this map in 3 decades. After that, we related and matched this data with the data present on the National Census of Agriculture of the data 1991, 21, and 2011. From the preliminary investigation based on the value of the delta NDVI calculated from the 99 to 2020 and from the subsequent change detection analysis along the time series, it emerged that since 1999 to date, the areas that have never been cultivated with arable land amount approximately to 600 square kilometers, while those the area that have undergone possible change in land use and or abandonment, they amount to approximately 413, as can be seen from this figure. This picture. When we speak about agricultural transition, we try to indicate the areas that during these 30 years have undergone agricultural abandonment and or change in land use, passing from cultivation to arable to another type of cultivation. This graph summarizes year by year the amount in square kilometer of these areas in the years analyzed. It's clear that the years in which there has been a greater transition of agricultural land use or abandonment are those relating to the second and the third decades. It's more difficult to discriminate and evaluate the abandonment area from 2010 to today, because this area may be subjected to vegetative rest and or crop rotation, and therefore need to further evaluation analysis in order to discriminate these. The data extrapolated from the general agricultural census represent in general the decrease in total from Basilicata region in arable land, and this negative trend confirm our results. In conclusion, the NDY time series dataset provide a high-quality data from the mapping of the phenomenon of the abandonment of arable land. The future improvements of this work is try to apply this methodology in other parts of Mediterranean area, like Sicily, like Apulia region, and apply the new algorithm for improved accuracy of the identification of agricultural transition and or abandoned area, try to distinguish this area from others, and then also try to apply the change detection analysis and match with the soil erosion map due to the application of Rusle method derived by the previous works. Thank you for your patience.
Okay. Thank you again, Valentina. Is there any question? Any question also from the people online attending this presentation?
No.
Okay. Okay. So no question. I thank you very much, all of you, for being here this afternoon. And okay, I think I thank for people that were here. I thank Valentina in particular for having run this kind of marathon this afternoon with three very good presentations, actually. And okay, thank you very much. We are on time. We are closing on time this session on geographical analysis, urban modeling, and spatial statistics. And I wish you a good afternoon and good continuation of ICCSA conference in Cagliari and on air. Thank you very much, and see you soon.
Okay.
Ciao Beniamino.
Salve, prof.
Vai, Beniamino. I'm muted.
Almeno per un attimo aria.
On.
Hartmut, are you online? No.
can hear you.
Okay.
I couldn't hear you.
Okay.
Good to see you.
Yes. With pleasure.
Yes.
Unfortunately, I haven't attended the session that you chaired because I had
No problem.
a boring meeting.
It
Our life is a continuous activity of boring meetings.
Yeah. No, the session went well. Just one paper didn't turn up.
Okay.
Okay, so
We
we had the others. I think we had an interesting mix. I will later fill the evaluation forms. So I think yes, it's a pity. All the presenters in the session I chaired met online only, so there was no one in Cagliari. But we all agreed we will have to meet next year face to face.
I hope next.
Yeah. So let's keep our
year
fingers crossed.
In Malaga.
In Malaga. I see.
In the south of Spain, on the sea, with
I know.
famous Picasso Museum also.
Yes, I've a colleague from this computer science institute. He has his second life in Malaga. Very good. So, yeah, Cagliari would have been very nice, but it wasn't possible due to these pandemic times. Even in Germany, I told you we got vaccinated so late. So, all right, what can we do? But actually, we as I mentioned, I can't complain, and it's good to see. It's good to see you, Giuseppe. Yes, I do recognize you. Very good. Yeah, it's a pleasure seeing you. It would have been much more pleasurable to talk to you in real life.
That's true. I miss that.
Yeah. All right, but from what I could see, I could report that this completely virtual session that I chaired, there was no technical problems. It went very well. We could see the presenters' presentations and so on, and it worked reasonably good, even with the questions.
Oh, Hartmut.
Yes. How are you, Francesco? Yeah, good to see you.
Next time we have to stay together.
Yes. It's got to be.
Yes, absolutely.
You have it seems it's a nice location again on the sea.
Yes.
Okay.
Yeah, and if you're on the right spot on that location, looking across the ocean, you can see the African coast.
Yes. That is a place where you left.
No, I haven't been there. I have been there virtually only, because a colleague of mine, he has a house there. And recently, we also had a video conference, and he turned his laptop to show us the bay of that place, and you could see on the far side the Moroccan coast with the Atlas Mountains. So you see, I'm trying to avoid the name of the place right now. Very good. Yeah, but it's a pleasure to see you, and hopefully all of you are doing rather well.
Mm-hmm.
I mean, this even in these circumstances, this really is something.
Yes.
Has any one of you contracted COVID?
No.
No, in the meantime. That's very good. But I know some people who afterwards had more or less severe problems. And I know one colleague who even contracted COVID after he was vaccinated twice. We know this can happen.
Yes, it can happen. Yes.
Yeah. So hopefully we'll get along well through this autumn and winter, and the pandemic is more or less over for those of us who are vaccinated next year, so we can move around much more freely than this is possible right now.
Yes.
Yeah.
We hope. I saw Sabrina lie in the room.
Yeah.
Sabrina, hi.
Hi, Liliana.
Liliana, hey. Sabrina is one of the best traveler of this period. She moved a lot, I know, and
Catania
last week.
Yeah, Catania.
And many other places, but she's completely immune from COVID. Yes.
Eruptive region.
because she's from Sardinia, so they have a different phenomena,
But it really is a pleasure to see you. This reminds me. I wonder if you know. Maybe it's although it is in English, it may be particular to German, because there is a TV show on New Year's Eve every year. It's a show of the 60s in black and white called The 90th Birthday. Anyone heard of that? It's a sketch where an old lady of the English landed gentry celebrates her 90th birthday, and she invites four dear friends for that evening. The problem is they're all dead. So it is the butler that people like that lady can command, who has to play all the four characters. And as it is a 3-course dinner with accompanying drinks. So I mean, during the dinner, the butler gets completely drunk, of course. And you know, when he leads this lady to the table, because she's the only person who's sitting at the table, and obviously she has a very poor sight, otherwise it wouldn't have been possible. He says to her, "They're all here, madam, for this occasion," and this is what we could say: we're all here for that occasion, but we don't get drunk.
Okay. We miss to stay together to tell this story.
You know, it started in the 60s. There is no German. It is completely in English, and it started in North German TV. And you know, many people who know the sketch completely by heart in Germany, and now it's become a tradition. You can see it all over in all places in Germany, in several TV channels. It's a 20-minute thing, and the funny thing is, all persons involved, the cameraman, the presenter, they're all dead. So it is a historic. It is a historic thing, and it's very funny actually, because if you think of it, you're a butler and have to pretend to be 4 persons, one after the other. You have to talk like them, you have to drink like them, and in the meantime serve a 3-course dinner. And as it is in an English gentry home, there is the skin of a tiger lying on the floor with a head. So of course this butler during the course of this event frequently stumbles overhead of that skin. It's very funny. I recommend that.
Okay.
It's little known in England though, and they don't find it too funny.
I will check for it. I
Okay.
say goodbye. I have to go to
Dinner. It's called Dinner for One, or the
dinner for
90th
one, not
birthday.
for 5, because the 4.
Yeah, Dinner for One or the 90th birthday.
Okay. See you later.
Right. See
Bye-bye.
you.
Ciao.
Bye
Uh, on 24 September,
Yes.
I had to be keynote in Belgrade, but just online.
Okay.
I cannot go to Belgrade.
Yeah.
What is the song conference or what?
Sara Matic organized. Do you know her?
No. I mean, this is on the architecture university or something, no?
Conference on sustainability technology, first conference at the University of but unfortunately I cannot participate personally, just online. Otherwise I will say you something in advance. You know?
Yeah, but it's is it complicated? Yeah, it's complicated to travel these days.
No, in our university, it's forbidden to move theoretically everywhere, but absolutely outside Italy. Italy is completely forbidden for us. The mobility is completely forbidden. Also, European project just online, it's not possible.
Yeah. It's tedious, but it's similar with my institute. It's at least very much restricted.
Yeah.
It's not forbidden, but it is restricted. So yes, online. I'm involved in EU project on East Jerusalem. We build a 3D city model with GIS functionality, and for all this COVID times, we're meeting online only. So that's not a very good situation.
Yes.
Yeah. I mean, it's complicated, and it's not the same. I mean,
No.
I don't know about this, the restrictions, but in general, personally and professionally, I'm a little bit, hesitating. It's not the same, and I have to think about so many things. So without relaxing, it's a little bit, it's not that nice, I assume. So
No. For instance, right now, you can't travel to Israel and then, for instance, move on to the occupied areas.
Yeah.
It's simply not possible.
Yeah.
And they can't come here either, of course.
I hope it's going to change. I mean, next year.
Yeah, our colleagues said there will be new regulations by the end of this month, because this month is the month of all important Jewish holidays. So after that, they announced, and from what they told us, they expect an ease of these restrictions. But let's see.
I hope for the beginning that
Live streaming is on.
Okay, something.
All right.
Yeah. Okay, I only hope that that the European Agency for the Medication, or how they call it, for the medicine, is going to approve all vaccines.
Yeah.
I hope for that. I'm vaccinated, but at the moment.
No. I mean, yes. If I, from what the Palestinian colleagues tell me, they're not vaccinated and there's no vaccine available. So it's simply not there, as it is an occupied country.
Yeah.
It is really.
Yeah, it's not going to be the same, but I hope near the same.
Yeah.
Near the same would be at least something. Yeah.
Okay.
So Benjamin is going. Valentina is going to present again.
Benjamin is doing the thing. Yes. He's giving the signal to begin, and we will shut up then.
Good afternoon.
We have Valentina.
Good afternoon.
Good afternoon.
Ciao, Valentina.
Okay. Okay, I can start.
Okay. Good afternoon, everybody. Welcome to the third session of geographical analysis for modeling and spatial statistics. This is a very small session, just one presentation. Just one presentation. Probably, if you attended at the previous presentation, you listened there a lot of times. If I remember right, just 3 times. She's Valentina Santarsiero, assessment monitoring soil erosion risk and land degradation in arable land, combining remote sensing methodology and RASL factors. Other authors are Biagio Tucci, Gabriele Nolea, Antonio Manorte, Giuseppe Cillis, and myself.
All right.
You can start when you want.
She's the workhorse of the track.
Can you see my presentation?
We can.
See my screen?
Yes, we can.
Yes.
Okay. Good afternoon to everybody again. I am again here, and this is my last presentation. That's concern of the assessment and monitoring of soil erosion risk and land degradation in arable land, combining remote sensing methodology and RASL factor. As I said you previously with my last presentation, land is a non-renewable resources, and I explained to you the different causes of soil degradation. Also, in this work, we analyze the soil erosion causes. Soil erosion, as I told you previously, is an extremely complex and natural phenomenon, and it depends on the climatic conditions, on the geological, pedological, hydrogeological, morphological, and vegetation features of the territory. But it can be accelerated by the human activity, in particular by agroforestry pastoral ones, like cultivation times, processing systems and cultivation, forest management, etc. In agricultural areas where specific agro-environmental control and mitigation action are not applied, erosion, especially its most in most intensive form. In fact, on the main ones under correct functioning of the lost. So the removal of the surface part of the soil rich in organic substance reduce the improductivity, and this can lead to in abandonment. Also, in this presentation, in this work, the studies area is the previous the studies that analyzed in the previous work, and the data set, I'm sorry, is the same. In this case, we also use the digital elevation model of Basilicata region. Also, in this work, we applied the Ruslan methodology in order to assess the monthly and annual soil erosion. Once the monthly and annual erosion rate A factor was calculated, after that the Gettys spatial autocorrelation index was used in order to obtain a persistent, non-persistent binary map consisting of 0 and 1 value, where 0 stands for non-persistent erosion and 1 for persistent erosion or permanent erosion, respect to the entire period observed period. The aim of this work is try to provide a tool for analyzing the phenomenon of land degradation on a large scale. One of the most important factors of the Ruslan methodology is represented by C factor, that concern of land cover management factor, which measures the type of management of the agricultural activity that is carried out on that soil, and can take value range from 0 to 1, where 0 indicated a good cover and agricultural management practice, while 1 indicated a condition of poor management and a condition on non-vegetated soil. In fact, the vegetation cover plays a very important role in determining the degree of vulnerability of a particular area. Through the T factor compared with the persistent erosion rate, it's possible to determine which agricultural areas are potentially degrading. In these areas, this phenomenon of alterated of photosynthetic activity due to organic loss or climate change or not, or incorrect management of arable land. This slide shows the methodology flowchart and the input map. The estimate of soil loss according to the Ruslan method is a function of the 5 variable explaining in the previous work, relating to the regime, the rainfall regime, to the characteristic of the soil, the topography, crop coverage, and the management and the conservation of cultivation practice according to the Ruslan formula. The methodology starts from the concept that in order to evaluate if are present a relationship between the erosion value of A factor and the C factor of Ruslan equation. This must be verified by trying to keep the other factor contributing to the final erosion value in a certain range. To do this, it was decided to use the slope and rainfall erosivity map divided in 2 classes, and to analyze the value of A factor in a range set by the classic for both slope and erosivity. And in this work, we analyzed the correlation between factor C and the erosion rate A. In this work, we also decided on the basis of the analysis of the monthly average of the R, A, and C factors obtained in the previous work to understand if there was a very strong relationship between them. We choose to analyze the month of March 2020, where the values shows a high erosion compared to a coverage of soil-related advances. The flow chart shows and reassume the methodology that we applied. This methodology development for the identification of potentially degraded areas. Arable land covered by vegetation is more protected from erosion because the leaf surface present interposes a physical barrier to the impact of the rain. Identifying the cultivated agricultural areas in which the erosion phenomenon is high, especially in the period where the growth of vegetation is high, implies that area could over time show problems caused by a not very luxuriant vegetation and increasing scarce growth, and therefore decided to, in the future, to abandon or change land use of this area. For this reason, by isolating the C factor from the other factor and linking it to the erosion factor in the periods of maximum vegetation activity, March, it is possible to obtain the degraded areas, as they show a high rate of erosion despite the soil being covered by vegetation. This map explained our results. This map is called the degradation map, degradation area, and the pictures show an example of this area. The pixel with the different red colors show and represent the amount of the degradation. In this picture are reassumed the detailed of the degraded area obtained, and it's very interesting to analyze this table, this results table. The municipality with the highest degraded surface is Tolve, with about 70 hectares with degraded surface to agricultural surface and agricultural surface ratio about 1%, followed by the Genzano di Lucania municipality with about 74 hectares. If the data of Genzano di Lucania can be discounted due to the huge cultivated area, in the case of municipality of Tolve, the phenomenon already seems to have a greater weight. Compared to the data on the relationship between degraded area and the cultivated area, and as interesting data to report refers to the municipality of San Chirico Nuovo, which showed the highest percentage of the ratio, with 1.48% compared to the all municipalities of the study area, to which particular attention by the government. In total, the surface of the degraded area is about 215 hectares, equal to 0.25% of the entire area intended only for arable land. So, in conclusion, this work is a first and preliminary study to delineate the soil erosion susceptibility areas and the spatial pattern of average annual soil loss, and identify the probably degraded areas subjected to abandonment. After the application of this methodology in other areas and in other periods, this methodology can be a useful tool to investigate the land degradation phenomenon with respect to the other factor that determine the potential erosion with a factor. And the soil erosion susceptible map may may be used as a a realistic tool for the preservation and sustainable planning of soil erosion in the area. Thank you.
Thank you, Valentina.
Okay.
With this presentation, you finish
My marathon.
your last effort. Okay. Questions, comments? And one or the other. It's not easy for me to for questions. Giuseppe, something to ask to Valentina? Okay.
I can hear that it is better, otherwise
Okay.
Well, I have to say that I had all the 4 presentations that actually Valentina presented this afternoon, and I also had the opportunity to read them during the preparation of the proceedings. So I did appreciate very much what she actually had done and what all of you are actually doing in Potenza as usual. And in any case, I did appreciate not an evaluation on a single paper, on a single presentation, but I think it is they are well defined and designed set of research that actually Valentina presented very well. So this is just my comment. I haven't got any particular question. I already presented some question before in the previous session, and yes, just a word of appreciation for all the research that you are carrying on and doing. That's it.
Thank you very much.
All right.
Thank you very much, Giuseppe.
Not at all, you're welcome.
Okay. You know.
Okay. If you like to close the session, I think that you haven't got other questions this afternoon.
No, I close this session. Thank you for participating at this 3 slot of GERMOD, and I invite you to continue to spend time with the other session in ICCSA conference. Thank you so much.
Bye.
Okay.
All right. Thank you.
Bye.
Bye.
Bye, Liliana.
Bye bye.
Ciao, Valentina.
Bye.
Oh, Vladimir.
Bye.
Beniamino, good to see you again.
Good. Nice. Nice. I hope next year.
Next year.
Yes. Always to organize ICCSA in your country.
Well, we'll try. If the social protests get down a little bit, we may organize it in Chile.
They continue. Also continue.
We don't know if they will continue after the pandemics, but we'll monitor that. I'll keep you posted on anything.
Okay.
Okay. Otherwise, next year in Spain.
Yes.
Okay.
All right.
Good to see you, Beniamino.
Yeah.
Nice.
Bye-bye.
Bye-bye.
Bye.